Hey calculus students, we're back for our next video on shortcuts to finding derivatives. In the last video, we tackled the first 3 rules, and today we're going to finish up this packet and tackle rules 4 and 5. So today we are going to be covering the product rule for derivatives and the quotient rule, product and quotient rule. So here's what they say down below. Let's just take a look at number 4 here, okay? This is the product rule, by the way, and you use it when 2 functions are being multiplied. Product means multiply. So whenever you're taking a derivative, that's the derivative of u times v. So 2 functions multiplied together with respect to x, this is the output. This over here is how you do it. So I'm going to read it to you. So it's equal to u times the derivative of v with respect to x plus v times the derivative of u with respect to x. Now, this notation right here gets a little crazy. Some people don't like all the dv dx's and the du dx's, so they'll use the prime notation, and they'll write the product rule like this: u times v prime, because v prime means the same thing as dv dx, plus v times u prime. And that's perfectly acceptable as well. But I got to tell you, when I was in high school, my calculus teacher taught me the product rule in words, and it has always stuck with me. I'm 42 years old now, and I still, when I do the product rule, I still say the words. So if you flip over to the next page, you're going to see that I wrote the product rule in words. Now remember, it's when you have a product, u times v, and in my words, I just want you to know that the u, I'm considering the first function, and the v is the second. So the first times the second, the first function times the second function. So check out the words. You take the first times the derivative of the second plus the second times the derivative of the first. The first times the derivative of the second plus the second times the derivative of the first. So it's the first times derivative of second plus second times derivative of first. And why they have to use u's and v's, I don't know, because they look the same to me, but make sure your v is really sharp. There it is. So if that helps you, first times derivative of the second plus the second times the derivative of the first, then use it. Okay, now back to the first page, the quotient rule. The other rule we're studying today is called the quotient rule, and you know you're going to use it when you see a quotient. So you've got the derivative of u divided by v with respect to x, and here's what it says, fancy fancy, v times du dx minus u times dv dx all over v squared. That's a lot to remember. Now, if you're a prime person, not Amazon Prime, if you're a prime person, it would look like this: v times u prime minus u times v prime all over v squared. Okay, because again, that's because du dx is the same as u prime. dv dx is the same as v prime. And we learned that earlier in another video. Yeah, so that's the quotient rule. Now, in words, because I'm a words person, I still do it this way to this day. So in words, now this is how I do it. If you have u over v, all right, so this is the numerator, this is the denominator. The derivative of u over v is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So here we are. So again, it's the denominator times derivative of numerator minus numerator times derivative of denominator all over denominator squared. I still do it this way, so feel free to steal it and use it And hopefully that'll help you to memorize these more easily. Okay, so now let's use them. Now, before we go into the examples, which are going to just be back here, example 4, I want to actually show you something that I wrote down on a separate sheet of paper. So if you have y equals 2x plus 1 quantity squared, you might remember this one from the last video. What we did in the last video is we wrote this out twice, okay, and we FOILed it. We FOILed it, and then we took the derivative term by term. Well, I want to stop here. I want to write it side by side, and now I want to use the product rule. I'm just going to do a practice run here on the product rule to see if we get the same answer. So I want you to think of this as u, and I want you to think of this as v. So we're taking u times v, and in words, you ready? Y prime, okay, using the product rule. So the derivative of this is the first, so I'm going to bring it down, 2x plus 1, times the derivative of the second. The derivative of this is just 2, because this is the slope here and this goes to 0, so times 2. So u times v prime, there's the first times the derivative of the second, plus the second, that's v, times the derivative of the first. And the derivative of 2x plus 1 we just established is another 2. So that's v times u prime. So first derivative of second plus second derivative of first. Now, cleaning this up, if you distribute the 2, you're going to have 4x plus 2 plus another 4x plus 2, and that is 8x plus 4 when you combine like terms. And guess what? That's exactly what we got yesterday when we did example 3, part C. We got 8x plus 4. We had FOILed it, but with the product rule, you don't even have to FOIL, and you get the same answer. Okay, now another problem we did yesterday was y equals 10 over x. What we did yesterday was we brought the x up and wrote it as 10x to the negative first, and then used power rule. Well, today we have quotient rule. So we're going to use this as our u and this is our v. So in words, when you have a quotient, the derivative is the denominator times the derivative of the numerator. Well, the derivative of 10 is 0. So denominator times derivative of numerator minus numerator times derivative of denominator. Well, the derivative of x is just the slope in front, the coefficient in front, 1. And this is all over the denominator squared. Okay, so this is v times u prime minus u times v prime all over v squared. When you simplify this, well, x times 0 is 0, so that goes away. Negative 10 times 1 is negative 10, and x to the second power is x squared. So there's the answer. Well, look at what we got yesterday, right here. Same answer. But now we have alternatives. So sometimes, it may strike you, hey, I'm just going to bring it up and use power rule. Sometimes your brain might take you the quotient rule route. These are more rules to find derivatives faster. Okay, in the packet, we'll finish up the packet by using the product and quotient rules to do A, B, and C. So letter A says, find the derivative of y equals 2x minus 5 over x plus 4. So top is the u, bottom is the v. And you know me, I like to do the words. So the derivative is the denominator, so x plus 4, times the derivative of the numerator. The derivative of 2x minus 5 is just 2. So bottom times derivative of top minus top 2x minus 5 times derivative of bottom. The derivative of x plus 4 is just 1. And this is all over the denominator squared. So again, this is v times u prime minus u times v prime all over v squared. Now I just simplify algebraically. So this is going to give me some distribution right here. So 2 times x is 2x, and 2 times 4 is 8, so 2x plus 8. And then 1 times 2x minus 5 is going to be 2x minus 5, but I do need to distribute this negative through. So I'll make this negative 2x and positive 5. And then this is all over x plus 4 squared. Okay, continuing to simplify, the 2x and the negative 2x will cross out. 8 plus 5 is 13, and this is all over x plus 4 squared. And that's the derivative. That's y prime. Now, students will ask me, Miss Callahan, should I square this out? Like, should I FOIL this? It's okay if you do, but I want to remind you what we just found here. This is y prime. This is going to be used to find the rate of change or the slope of a tangent line at a curve at any value of x. To me personally, it's easier to plug an x value into this and then add 4 and square than it is to put it into this. What would that be? X squared plus 8x plus 16 if you FOIL it. You can do it either way, but to me, it's just easier to use this. So you got to remember what you're finding, and you kind of have to use your gut instincts to know when to stop, how far to go, and that will come with practice. Obviously, if it's multiple choice and you're looking for a derivative, you'll be able to see how far I went. But for this, just kind of use your gut, know that you're plugging in to find a slope, and just kind of stop where your gut takes you. Okay, letter B. Find the derivative of this product. So I'm going to use the product rule here. So I've got y equals a u times a v. So my derivative, y prime, again, I'm using the words, is the first, so I'm going to just bring down x squared plus 1, times the derivative of the second. Well, the derivative of x to the third plus 3 is going to be power rule, 3x squared plus 0. So I'll just leave it at 3x squared. So first times derivative of second plus second, x cubed plus 3, times the derivative of the first, and the derivative of x squared plus 1 is 2x. Okay, so again, that was, if I'm using the notation, u v prime plus v u prime. All right, I could distribute here and see if I can collect any like terms just to simplify this. 3x squared times x squared would be 3x to the fourth. 3x squared times 1 is just 3x squared. 2x times x cubed is 2x to the fourth. And then I've got here 6x. So putting my x to the fourths together, my final answer, 5x to the fourth plus 3x squared plus 6x. And this is the derivative by the product rule. Now, before we leave this, I just want to say, you could have done this differently. Suppose your brain would have said, hey, FOIL, because you can multiply two binomials together by FOILing. So maybe you would have come over here and said, okay, by FOILing, I'm going to take x squared times x cubed. Okay, that's x to the fifth power. X squared times 3, that's 3x squared. 1 times x cubed, okay, that's x cubed. And 1 times 3, okay, that's 3. I don't have any like terms, so I'll just leave it like that. So now I'm going to do the derivative by the old school rules, which is basically just the power rule and the constant rule here. So x to the fifth would become 5x to the fourth. 3x squared would become 6x. x cubed would become 3x squared, and 3 would become 0. Now look at this and look at this. If you just arrange these two back terms and flip that around, you've got yourself the same derivative, and that's okay. It depends what you want to do, but you have options, all right? Same derivative, different method. Okay, last but not least, write the equation of the tangent line to f of x equals 3 over x plus 2 at the point 1, 1. I'm actually going to bring this down here because I didn't like the way it returned there. So f of x equals 3 over x plus 2 at the point 1, 1. Now, you got to think back here. We did a lot of equation of tangent line writing when we were doing derivatives the long way with the limits. We haven't done one in a little while here. So what we're going to do is we're going to find the derivative of this function. Now, let's just quickly, my visual people, you know I got to do a shout out to my visual people. If I were to graph this using techniques from Unit 1, I would know that if I set the denominator equal to 0 and solve, I would get x equals -2. And if I evaluate f of -2, I get 3 over 0, indicating that I have a vertical asymptote when x is -2. So let me come over to -2 and get my asymptote in there. Okay. I also know that if I do a limit as x approaches infinity of my function, as well as a limit as x approaches -infinity of my function, that will give me any horizontal asymptotes I may have. Well, if I plug infinity in here, I'm going to have 3 over infinity, and that heads to 0. And if I put negative infinity in here, I'm going to have 3 over negative infinity, and that heads to 0. So y equals 0, my horizontal y equals 0, is going to be my horizontal asymptote. Okay. I can figure out if I'm heading up or down at my vertical asymptote by evaluating the limits to the left and to the right of -2. So I might do that. Oh, where can I go here? Go down here if I can fit it here. So the limit as x approaches -2 from the left of 3 over x plus 2 would be 3 over, let's see, -2 left, that'd be -2.01 plus 2. And that's going to give me 3 over -0.01. And we know from Unit 1 that's heading to -infinity. So coming into -2 from the left, I am going down to -infinity, which means my graph is going to go like this toward the asymptotes. Now, if I do the limit as x approaches -2 from the right of 3 over x plus 2, then I have 3 over -1.99 plus 2, which is 3 over positive 0.01 or positive infinity. So I know that as I'm coming here, I'm coming up. I could grab my y-intercept by quickly evaluating f of 0. F of 0 is 3 over 2, which is going to be 1.5. So 1.5 is about right there. So I'm going to cruise through there and head toward my asymptote. That is a quick sketch with some scatterbrained work here of this rational function. Now, but look at how much this helps me figure out what I'm doing here. Go to the point 1, 1. Look at this, 1, 1. It's right there. I'm going to be writing the equation of the tangent line right at that point, 1, 1. Well, in order to do that, I need the slope of that tangent line. And the concept in mathematics that finds the slope of a tangent line is derivative, but we no longer have to do it the long way because we have shortcuts. And the shortcut I'm going to have to use here is the quotient rule. Okay? U and V. So, the derivative of this quotient, the slope of the tangent line to this graph at any point, is going to be given by the denominator, x plus 2, times the derivative of the numerator, 0, minus the numerator, 3, times the derivative of the denominator, which is 1, all over the denominator squared. Okay? This is v times u prime minus u times v prime all over v squared. When I simplify that, this x plus 2 times 0 is 0. I'm left with negative 3 over x plus 2 squared. Now that is the derivative. This will give me the slope anywhere along this graph that I choose to evaluate it at. But we wanted it specifically at 1, 1. So it's easy. So all I do is take my f prime of x and make it f prime of 1 because the x is 1. Okay? So when I do that, I get negative 3 over quantity 1 plus 2 squared. Well, that's negative 3 over 9, which reduces to negative 1/3. That's a really, really good sign that I got a negative because look at the way that line is sloping. That red line has a negative slope, so that's a good sign. So I just finish it off. So my final equation in y equals mx plus b form is going to be y equals my m, which is right here, negative 1/3 x plus b. And to get b, I'm going to substitute in my x and my y. So 1 equals negative 1/3 times 1 plus b. And solving that, 1 equals negative 1/3 plus b. So when I add 1/3 over, my b is going to be 1 1/3. And that looks reasonable as the y-intercept there of the line, doesn't it? It's a little under 1.5. So my final answer to this problem, I don't know where I'm going to put it because I've run out of room, but my final answer, I'll put it right here. The equation of the tangent line at 1, 1 is y equals negative 1 over 3x plus 1 1/3. Final answer. Okay? So thanks for watching. 2 more rules, product and quotient rule.